This is week number 3. And in each week, we have a meet. I call them exercise meetings. So we meet. Sometimes I say stuff in between the exercises, stuff on top of the notes that we've provided to you so that we are guided. But I always want to start by telling my students, why are we doing this descriptive statistics even? Descriptive statistics. And last week we focused on summarizing and organizing data. So if we touched on frequency distributions. So the reason for that is that data on its own, when you collect data, it doesn't make sense to us, the researchers, or even anyone who is attempting to make sense of it. So that is why we use the graphs, the frequency distribution. There's a simple one, there's a grouped one. But the intention is to construct or sketch the graphs. And the main graph that comes from this is the histogram. So the histogram is used mainly because of inferential statistics. We're going to touch on that in week number 6 or 7, if I'm not mistaken. So you see there are polygraphs, there are whatever, but they're not used a lot. But if the data has been measured at a categorical level, there's a use of bar charts. I saw someone on Padlet, they presented a kind of a bar chart, but they wanted to construct a histogram. That is incorrect. Let's say if there's a question on assessment, if you do that, you get a 0 if it's out of 5. You can mute your mics, please. I'm not sure who want to speak, but don't speak now. So that is why we did that last week. So we did that to organize and summarize the data. But summarizing and organizing data is not enough. So let's say we have a sample. Researchers would want to describe the scores from that sample. Like for example, we want to know if students are satisfied with exercise meetings. I'm just saying. Let's say, are we happy with this, what we are doing now? Okay, we don't know. Let us ask them out of 5. So someone 4, someone 3, someone 2, someone, whatever scores that we have. But how do we report it then? What do we say to someone who wants to know? So that is when we make use of the central tendency. So in statistics, mostly, the mostly used is the mean. People call it the average in the street. We call it the average, is the mean. So the mean is the value, the data point that is representing all the scores in a distribution. That mean is associated as well with the mode and the median. So those 3 goes along and together mostly just to describe the central tendency. So if the distribution is normal, we expect all 3 to be equal. So if everything goes accordingly. So the mode, the median, and the mean, they should be equal. So the one that is reported, if you read journal articles, is the mean. But okay, let's say we say the mean is 3 out of 5. Can you say everyone is satisfied with the meetings? Okay, maybe yes, maybe no. There's something that we don't see when we report that mean only. We want to check how are the scores spread or close to each other. So that is variability. It is very important because sometimes we can get a 3, a mean, but we have a lot of 5s and a lot of 0s. So if we add them and maybe divide by the number of scores, we get a 3. And we can have another sample where students have scores of 3 and 4 and 5, 3 and 4. If we add even the same, we can get the same score of 3 in comparison to the one with the 0s and 5s, of which is problematic. But anyway, so that is why we report on the standard deviation. So although we calculate variance, the one that is reported when you read the journal articles is the standard deviation. What researchers expect is to have a standard deviation that is 0, meaning the standard differences from the mean of the scores is little. So that's what is expected. And that normal distribution is like a bell shape, if it is like that. A bigger, I don't know what is bigger at this stage, is not expected, it means we have that's the problem of we have a lot of scores with zeros and maybe 1 and 5. So it means we cannot kind of report with confidence that mean of ours, because that mean is actually a representation of scores that are widely spaced. So it's a problem. So when we report in inferential statistics, when we want to generalize the findings, we report that with caution, because the scores are widely spaced. That is the reason researchers randomly select the participants. We do that in trying to balance that, hoping our standard deviation will be close to the mean. When that happens, we are happy, we clap hands for ourselves. We can run inferential statistics perfectly. Okay, that is the theory around it. There are formulas that we use for such. So we have two. We have central tendency. If you read the chapter, I think chapter number 4 and chapter number 5. I'm not sure which textbook you have, chapter number, but so we are reading those two chapters. So the mean and the central tendency and the variability. So those two. So that is descriptive statistics. So under the central tendency, let's start with the mean. So we are going to do two exercises together. Let's do it quickly. So chapter 3, chapter number 4. Okay, I wanted to ask this. You can answer this at the end. How are you doing? Do you understand? But I've kind of provided you a summary. That is a very important summary that I've just provided to you. And how are you staying motivated, even when you have load shedding and whatever that is happening in life? At the end of this, we'll be able to calculate all this. Even if you go to our Padlet, the same questions, so you have a good understanding. And I've just managed to explain why are we doing all that. And we managed, I think you are convinced. So you get scores like this. We can have Penny, let's speak quick and let us allow, if you speak once, allow other children to speak afterwards. We want everyone to, even if you are shy, like myself, you can write aside and check if the answers are correct. So that we move on quickly, not for the sake of being quick, but we want to get done. So we start with the central tendency, of which is the mean. Excuse my writing, I'm left-handed, but I use my right hand to write this thing. The mean, the mode, and the median. Can someone tell me what is the mean and how do we obtain such? You can unmute, and I'm not seeing your names because I'm sharing this. Let's try to to be organized. I expect people raising their hands, but actually, yes, Simon.
So for the mean, do you
don't ask us, tell us.
Okay.
Yes, we approach everything we do with confidence.
Okay. I'm gonna try remember it. So for mean, we take all of the scores that we have and we put them, so the frequency, so we'll put the number 1 3 times, and then we put all of those numbers down and we add them together, and then that the score that we land up with, we then divide by the amount of times that number showed up.
Which number?
So if I have, so it's going to be 3 1 2 2. So X is 1 and F is 3. So X showed up 3 times, 2 showed up once, 3 showed up 0, 4 showed up twice, 5 showed up twice. And then we take 3, 4, 5, 6, 7. So the number that we added together to get our answer, we then divide by 7.
Where is 7 coming from?
The frequency.
So we are adding this plus this plus this plus this.
Yeah, yeah.
It's not 7.
Oh.
Can you do it again? Check. It's not 7.
3, 4, 5, 6. Sorry, 8.
Okay, 8. Okay. So what we add again? Okay, 8 is correct. Thank you. We divide by the number of scores in a distribution. That's what you're saying. That's what you're looking for. But what about this top? Which values are we? Which one can you just? Let's start with this one. What we add? So we are adding all the scores and divide by the number of scores that are in a distribution.
Yes.
So which scores? Which ones? I'll write here for you.
Okay. So 1 plus 1 plus 1.
Okay, thank you. And that's 3 and?
Plus 2. Plus 4 plus 4 plus 5 plus 5.
Thank you so much. So what is the answer for that?
1, 3, 6.
It's 28.
15.
25.
Okay, hold on. You say 15, someone said 28, someone said 25. What is the correct answer?
20. Oh, sorry.
So when you take your assessment, don't rush yourself like that. You make a mistake.
Yes.
Yes. So take it. Just others are busy calculating. So we are working with you now. You are teaching us, teach us. Yes. So 1 plus 1 plus 1, and so that's 3, and then plus 2, that's 5. We don't have a 3. Plus 8 plus 10.
Yes.
10, 18, 20, 20. What's the answer? 23. Am I correct?
Yes, I got 23
Yeah,
as well.
it's 23.
Yeah, 23.
Same. Okay,
Yes,
sorry.
thank you so much. Yes, 23. Like this. So 8 into 23. That is the mean. What is the answer? We round off to decimal places in this model.
2.88.
Okay, 2.88. Is anyone? Can you raise your hand? It's your life. Don't be shy. We are here for this. Hi, excuse me. Hold on. What did you do again? That is why we are having this meeting. If you got 5, like you raise your hand. Hi, Chablani. Wow, I got 5 because I did this. Where is it? Where am I wrong? So the mean, the mean, you add all the scores and divide by the number of scores in that distribution. Okay. So do not add 3 plus 1 plus 2. Do not add 1 plus 2 plus 3 plus 4 plus no, but we have 3 scores of 1. We have an individual 2. We don't have a 3. We have 2 scores of 2. We have 2 scores of 5. If we add that, we get 23 divided by 8, 2.8. What is the mode? Someone different? You just explain what is the mode and then what is the answer?
Jablani.
Yes.
Okay, so mode is the number which appears the most, which is the highest, has the highest frequency. So it would be 1, because 1 appears 3 times.
Thank you. Some students write 3. Don't do that. They write 3 as in 3 is not the value. 3 is the mode, as in the value, the appearance of 1. How many times is the score of 1 appearing? So 1 is the value that appeared most in the distribution. So most of the students we asked, they had the score of 1 out of 5, if I can say so. That's what it means. So the most appearing or the most frequent value. Anyone with a question on that? Not 5, not the largest value, no, but the appearance. So you look at the frequency. So they are the highest number or the highest value here. That is the mode. Okay. And the median, someone to help us with the median? Someone different? The median, let us move fast.
Or do you just put them in ascending order and then find the middle number?
Okay, thank you. Okay, some of us don't know what is that ascending and descending. What's that?
And just like in order of size, so 1, 1, 1.
Okay. So 1, 1, 1,
2, 4,
2.
4.
We don't have a 3, is it? 4,
No.
4,
5, 5.
5, 5. So we have 1, 2, 3, 4, 5, 6, 7, 8 values. So what do we do then?
So there isn't a middle number. So the two numbers, well, this is what I think. The two numbers in the middle are 2 and 4. Do you average those, add them together and divide by 2?
Yes, so we add and divide by 2. Yes, thank you. So if the values are even, the even number, we do that. But if it, let's say we didn't have this 5, we're going to identify 2 as going to be the median. So the number that is at the middle, even if you arrange in ascending or descending order, it doesn't matter. From the largest, from the smallest, it's not a big deal. So this is, the answer is what, 3? Okay, we add 2 plus 4. That's 6 divided by 2. The answer is 3. And we are done. That is the central tendency for this. But now, anyone with a question with this? This is quite, I think I'll use the word easy for now. But we have, I don't want to move 5 slides here. Let me check, let me see what I wrote, what I have. Why did I change this? We don't have time to have a lot of exercises like that. What's this now? Well, let us focus on the first one, the one that okay, let's do this one. This doesn't make, so that we have everything. But I want you to, can you take a picture of this? Okay. And before, I want to explain something as well. So where is my variance for a sample is this. Variance for, I can't write it properly. For a population is this. The standard deviation for a sample is this. The standard deviation for a sample is, you have seen that in the book if you read. Excuse my sketching. That's it. I think in a quiz there's a question like this. But anyway, so that is what they wanted to write. But anyway, let's move on. And I said in a Padlet, use the computational formula for a reason. That is the widely and mostly used in statistics. But now let us go back and do this exercise. So we have that mean of 3 and whatever, but we trust that mean. So for us to explain all that, I'll come back to this. Remind me to come back to this a little bit later. Not later, I want to get done. So for us to calculate the range, you take the largest number and subtract and minus the minimum, the lowest number. So it's max minus minimum. So the largest value in a distribution, and you subtract the smallest of it. So if we arrange these scores, for example, so we have 1, 1, 1, 1. We have 2. We don't have a 3. We have 4. We have 4. We have a 4. We have 5, and we have a 5. So this is what I mean. So it's 5 minus 1. That is the range. Rarely reported in statistics, but it's actually showing that actually we have a problem here. This sometimes it is reported in relation to the mean, like there's what it should not be double the size of a mean. You can read that somewhere around. But what I want us to know in this exercise is how to calculate it. So it's 5 minus 1. The answer is 4. Okay, that is the range. And then now, this is quite easy, but we need to calculate the variance. So the formula for variance is, for a sample, is SS divided by n minus 1. The formula for variance for the population, for a population, is SS minus n. Okay. So for us to calculate such variance, standard deviation is the square root of this, like this. And then now the formula for this is sum of x squared minus, so the sum of x. You remember last week I told you to come back with knowing this, and then we know how to do it, all of us, I think. So now we need sum of squared values. You remember from last week? You remember that? So can someone tell us how do we calculate this? This is the formula.
Jabulani, can I try?
Yes, thank you.
Okay, for EX square, I think
It's
we
not
have,
it's sum of, it's not E per se, but let's call it E.
okay,
Yes.
sorry. Okay, so for sum x squared,
Mm.
we're gonna take each frequency and we're gonna square it, and we're gonna add all the frequencies.
Like this.
No. We're gonna do 1 square plus 1 square plus
Okay,
1
no.
square
So
plus 1 square. 4 times.
each value, not frequency. So
Okay, yeah, sorry.
each value. Okay. So we square this, like that.
Yes.
Okay, and then find
We're
it.
gonna add all of them.
What is the answer? Someone? I think there's someone who is quick here. What is the answer? So we square all the values.
Okay, I'm just gonna work it out.
Can someone help us, please? We are here to work as a team. Can you help us, please?
I got 106. I don't know if it's correct.
I don't even know as well, but let's trust them. Can someone please proceed to calculate if we get 106 as well? And while we are at that, can someone explain to us about this now? Now we want to subtract this. How do we get this?
Sorry, Jumbo, can I ask a question, Jabulani?
Yes.
Is it the same if you take XF, like, calculate XF for each row and then square that and add those? That would be would that be a different result?
Yes. Like last week, if you check the Padlet, people who did that, they got the answer wrong. I didn't want to check how is it. I thought it can come up to the same, but I think there's a difference. I don't know where now, but for us to understand it in an easier way, let us do like this. And later, I want maybe you to do it separately and check if we get the same answer. Maybe we do.
Sorry, I tried it. It comes up to a larger number.
Okay.
Because now it's not going to be 1 squared plus 1 squared plus 1 squared. It's not going to end up to be 4. It's going to end up to be 16 instead of 4.
Okay, see now, yes.
Got it.
So yes, thank you so much. Yes. So you tried that. So thank you for trying that mistake. It was last week. People.
It was last week. I did it wrong last week.
Oh, is it? Now, and I think I commented. Is it? I think I commented like, don't do like that. Kind of. I'm not sure if I did that, but that's what I checked. I think 3 people did that. So
yes, you did. That's what made me double check it.
Okay, thank you so much. So let us do this. Okay. And can someone tell us this, please? What do we do? Just unmute. Let me pick on people that are not even speaking. Okay, someone who are speaking now. I see. I was not seeing your hands. I'm not seeing your hands. You can speak if you want, and if you can. I don't know who are speaking now. Let me.
Are we doing the next part?
Yes, no, let's go to someone different. I have my people that are,
Yes, well, is here.
yes, well, so thank you. How are you?
So I'm good. And how are you?
Yes, I'm good.
Okay, let me attempt. I think that is the sum of the values. You add all the values. That is 1 plus 2 plus 3 plus 4 plus 5. And
Which
then
one?
you
Can I hold on? Hold on, 1 plus?
x, you add 1 plus
Yeah.
2
Mm.
plus 3 plus
Mm.
4,
Mm.
5.
But we have 4 ones.
Mm,
So that is incorrect. So we are adding these scores well.
okay.
So what you did, that is why you're having these exercises. So you get it wrong if you do that, because we are saying how many ones do we have, and it's saying we have 4 of them. So if we add 1 plus 2, we have missed 3 ones.
Okay, yes, I see.
Yes, thank you. So we are adding 1 plus 1 plus 1 plus 1 plus 2 plus 4 plus 4 plus 4 plus 5 plus 6. So we can do what I forgot you were saying earlier, like we can even multiply them like this. Yes. What is the answer then?
Okay.
So
Hi,
22.
so I got 28 for the answer.
Okay, 28. Thank you. Yes. So that's what we do. We are adding each score, and we are going to square it and divide by n. What is n? How do we get n? How do we know about n here? You add what? The frequencies. Yes, thank you. So it's 4, 5, 6, 7, 8, 9, 10. Even if you count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we divide by 10. So what is the answer then? Someone
So
different.
the answer for 28 squared was 784.
Mm.
And then
Right.
if you divide that by 10, it's 78,4.
78. So
I'm just doing the other. So
Okay.
the final answer I got was 27,6.
Okay, let's start here. What 70? What 78.4? Let's do decimal places. 40.
Okay. I just
Two
got
decimal
4.
places. Okay, so it's fine. It's fine. And the final answer is
27,6.
okay. And then what do we do now? Remember, we want to calculate the variance. What do we do? What is this? It is the sum of squares, is it? So now we need to complete our formula of 27.6 divided by, if it is for a sample, like what I've just wrote somewhere, I think I deleted it. Okay, this one. For a sample, it is n minus 1. So we said we have how many scores again? 10. 6, 7, 8, 9, 10. Did you say 10? Yes, 10. So it's 10 minus 1. So what is the answer for our variance?
I got
3.07. Sorry,
No, sorry.
3.07.
So
I got
3
the
point?
same thing, yeah.
What did you get? Can you repeat again?
3.07.
Okay, 3.07. Okay. Thank you. Are we following everyone? Don't be shy. Like, excuse me, go back. What did you do there again? That is why you're having this meeting.
Hi, so I have a question.
Yes.
So I understand all the calculations we've done, but the sum of x squared minus that whole equation, is that what is that for?
Is this?
Okay, so that's how you work out SS.
Yes, that's the formula for such. Yes.
And then that's for variance.
You know, variance is the whole. Okay, let me delete. So variance formula is this. For a sample, for a population is this one. So we cannot proceed without first calculating the sum of squares. So the formula for this is this one. So that is why we did this. And then we found 27.6. And then this one is n. How many participants were in a study -1. It's actually degrees of freedom. And then we divide by that. So it's 9 into 27.6. So the answer is 3.07. Standard deviation is easy because standard deviation is the square root of the variance. So it means the square root of so that is standard deviation. What is the answer for that? So you punch some calculators, you punch the number first. Some you punch the square root first and then punch in the number. I don't know what to do with yours. 3.07 square root. What is the answer?
So 1.75, I think.
Yes, 1.75, yes. So if you calculator is 1.752, but that 2 doesn't change the 5 because we say we are rounding off to 2 decimal places. So it remains 1.75. Only. Nothing else. Mean, median, mode, range, variance, sample. But sometimes the question doesn't say for a sample yet. It says for a population. So the difference is that we are going to divide by 10, not by 9. That is the difference. So it's going to be 27.6. This remains the same. Divide by 10. So the answer is 2.76. That is variance. And the standard deviation, so the variance, remember I said the variance for population is this sign. I can't even draw it. You will see it when you read the textbook. Have you seen it? What I'm talking about? And then the standard deviation. What is the square root of this?
1.6, I guess, or 1.7.
Yeah, thank you. 1 point, let me see. 2.76. Okay, 1.66. Okay, we have questions.
Okay, Jabulani, I'm here stuck at standard deviation.
Yes, okay. So,
Okay,
but at variance, do you know? Okay, you can explain?
Yes, variance and stuff I understood. Okay, I got for variance, I got 3.07. Okay, so now for standard deviation, isn't the formula 3.07 divide by the number, which is going to be 10?
No, standard deviation is the square root of variance.
Oh, okay.
The formula on its own, the formula for that on its own is this.
This is the variance of sample formula, right?
No, this is the standard deviation.
Standard of deviation.
And for variance is this one. Do you see the difference? The difference is square root.
Yeah, I got that. So we're supposed to do the root of 3.07 over 9.
That is no, we are square root the variance 3.07. So the square root of that is 1.75.
Okay, yeah, you see, that's where I'm stuck because the standard deviation of sample formula is S over n minus 1.
Let's go back there. What is our SS again?
SS is 27.6.
Okay, let's do that for you. 27.6.
Yes.
Divided by
10 minus 1.
10 minus 1 in a square root, is it? That's what you want, is it? Like
Yeah.
this. Okay, let us proceed. So what is the answer for this?
Okay, just a second. 27. 3.07.
And then we are not done because that 3.07 is in a square root. So we need to remove the square root. So that is why we are saying it's the square root of this. So if you remove the square root, it becomes 1.75.
Oh, okay.
Yes. It's the
Yeah,
same.
I was querying root. Yeah, I was doing something else. Thank you.
Okay. So it's the same. So you don't have to go back and do, so it's the square. And then I'm actually teaching you that the standard deviation is the square root of variance. If you read also, you get that. Okay, anyone with a question? You see some funny values though, like in the assessment, they'll give you values with decimal places. That is the difference on, but actually it's the same. What you do is the same. And students usually get confused with these values. But we did that last week, and I even explained that please master this. We are going to see that. Yes, let me check who is raising the hand. Yes, let's start with Jandy and then go to Simon.
Okay, so Jabulani, so if we work out the variance for a population, how would we do the standard deviation for
same.
it? Would the same, okay.
Yeah, it's a square root, yes, it is.
Okay.
Yes, like this, I did this.
Let's
Like
do it,
yeah.
yes,
Yeah.
over the end, yes.
Yes.
Okay.
Okay. Anyone with a question? I'm not reading the charts. Let me see what's there. Hi, thank you. Calculate from there. The variance, not variant. Okay, I'm late. It's fine. We are recording. Am I recording? Yes, I am. Otherwise, we're going to start the meeting again. Okay, I see. Thank you for the chats. Who is raising hand? You can unmute and speak. Okay. Is there anyone else? Yeah, but I think we are done, is it, with the mean? So if you go to our Padlet, I think everyone's going to get that correct. It's not for the sake of getting the Padlet correct. It is for you to understand. Okay. I'm teaching you so that you understand. Okay. There's a funny, what you're going to see, I'm in the dark, we don't have power here. What you're going to see as you read is can you find the precise median? Like the exact, let's say the values are, we measure at the continuous level. So this median that we're calculating is not the exact median because of the real limits. So you can be asked to identify that precise median. So the easiest way of doing it, you construct, I wanted to do something, but I forgot. You construct a histogram like this. Let's do this one. And that is 1. We're almost done. 3, 4. You see that when you read, but don't be scared. I didn't see an assessment with this, but I'm just telling you to. If I set the assessments, I include this question. Luckily for students, I'm not setting this. 1, 2. So they use it for F1 and among others. So what you do, you sketch a histogram. How many scores of 1 do we have? You have 4, is it? So it's somewhere here. Remember, it comes here. So you construct them in blocks like this. So what you want to do, you want to have equal blocks on each side where the middle point is. Remember, I'm saying continuous because where this line is actually to 1.5. Remember the real limits, 1 is 0.5 up to 1.5. Anyway, let's proceed. We have a single score of 2. Okay, so it's like this. We don't have a score of 3. We have how many excuse my, and then we have 2 square root of 5. Which page number is it on the textbook again? I'm forgetting. So what we want to do, this one is easy, I made a mistake. So we want to find a precise median, like exactly where it is. So we want to divide this block. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We want a point whereby there's equal blocks on each side. So this one is easy. So we draw a line here for that to happen. My line is cutting across 3. Yeah. So the median is where the line is cutting it. That is 3. But let us assume that there was another block here. Okay. Let me delete this. Oh, not undo. I want to erase. Okay, fine. Where do we draw that line? Where we have, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We need 5.5 and 5.5 on each side. Where do we draw that? Well, actually, let me do this. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6. So we want to have 6 on each side. Where do we draw that line? Can someone tell me where we can do that? Where can we draw a line where we end up with 6 blocks on each side?
In between 3 and 4, I guess.
Yeah. Is it here?
No.
Okay.
A little bit overlapping, like coming.
Okay, so in between 3.5 and 4.
Yeah.
Okay. That's a quarter. Where exactly? What do you mean? Okay, let's draw what you're talking about.
Yeah, that's after that I don't understand anything.
Okay, but thank you for trying. You are on the right direction. So if we put it a quarter, if we have a quarter, a quarter, and a quarter, it's not a whole block. It's a 3/4 block. So we have 1, 2, 3, 4. And if we add all the 3/4 and whatever, but if we count 1, 2, 3, 4, 5, it's not a 6th block because this block is a quarter, quarter, quarter. So it's going to be 5 and 5.75 blocks. And this side has got 6.25 blocks. So where do we must push the line a little bit further, is it? So we push it a little bit further to make it a third. So that for these 3 blocks, there's a third that is taken from each block, and there's a 2/3 that is taken from each block. If you do that, there will be equal number of blocks on each side. But now where it comes to is where is that line crossing at? So that is the precise median. So I want you to go and find out and tell me in the Padlet, what is the answer for that? This line is not crossing at 3.5 because 3.5 is here. This line is not crossing at 3.75 because I don't know who spoke earlier. Because at 3.75, we are left with a quarter of a block less. So I don't want to give pressure to you, but I want you to go and read it and give me the answer on on the pedlet when you have time. But it's rare that we ask that question. But sometimes it can happen. But when I check the assessment, that question is not there. So I'm just saying this so that, okay, Jablani, what about the precise median? So that is what you do. You find a line that is crossing whereby you divide all the blocks equally. So when that line is crossing, is the value for such. I think this is 3.5, and this is maybe 3.7 something, maybe 3.8, maybe 3.9. I want you to go and find out. But the rest, this is what is important. This, and this. So I was explaining this now. So if you know how to do this, yeah, okay. But sometimes also the last thing before you leave, the question is asked, you are given a distribution like this, and then they ask you to identify if the distribution is negative or is it positive. So we are asked to identify if the distribution is negative or positive. So the easiest way to do that is to construct a histogram. And when you try to draw a line, if you identify a line like this, excuse me. So from theory ways of it and of explaining a negatively skewed is this, and a positively skewed distribution is almost like this. What it means that if we try to construct a histogram with whatever scores that we have, for a negatively skewed distribution, we have, so let's say this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. For a negatively skewed, it means we have less. What is in English? we have less little numbers. Is it correct English? Meaning we have, let's say in this circumstance, we're supposed to have 1, 2, 3, 4, kind of like that. So if we want to construct a histogram, it's going to end up like this. If we want to draw a line on top of the graphs, it can end up like this. That is a negatively skewed distribution. And vice versa, a positively skewed distribution means that we have a lot of small numbers, smaller values. We have a number of them in comparison to the larger values. So we have very little 5s in comparison to the 1s. So it can end up and come up like this. So this is a positively skewed distribution. And the intention of research is to have, like what I said last time, is to have a normally distributed distribution. My case is not moving. I do apologize. We need to have this. This can happen if the mode, the mean, and the median are equal, and the standard deviation is very close to that mean. So we can come up with something like this. And when we have such, that is when we can generalize the findings to the whole population. So that is descriptive statistics. And as you read, lastly, when you read your this section of the mean, you see how can we change the mean, especially when you add a score, or when you subtract a score, or when you change a number, a value, what happens to the mean when such happens. So please read around that. I think on a quiz, there's a question like that as well. So you'll be sorted. I think at this point, at the stage, I've managed to cover, and we have managed to cover what is important. Next week is quite easy. Not quite, it's actually easy. But you start to make use of, you'll be introduced to the tables at the back of your textbook. So try to familiarize yourself with them. If you don't watch a recording of next week's meeting, you are most likely to struggle with week number 5. That is according to my experience, week number 5 is the most difficult. Okay, but we do it together. We do it for its probability. Most people don't like it even. They freeze when there is that stage. But we are going to do it together. We have videos for you. We record. We ask each other questions. We do it together like this with a Padlet. I think we are going to come out victorious. Questions, comments before we call it? Is it still evening or is it night now?
It's night, I feel.
Okay, it's a feeling. I think it's evening. If we start a kind of, let's say there's a function, you say, good evening, ladies and gentlemen. Is it? I think it's evening. I don't know who told us to say that though. I heard another, these were the formulas that we're using. And this is what I explained about the skewness. And this is what I was explaining to you as well. Quarter, 3/4, this is quite easy. So our line is a little bit further than this. So go and find that out. I'm going to come back. I see 2 hands raised. And my name is Jabulani. Let me write for you the formula for next. Are these old hands or new hands? Not old as in a person, but hands that were raised earlier. Simone and are these new hands?
Jabulani, just one more question. Can you just explain what happens to the standard deviation when you've got a normal distribution? Just briefly.
We don't know, but actually it means the standard deviation is close to the mean. So
Okay.
it depends on the mean. We don't have that value, but it means the scores are distributed evenly. That is what it means actually. It means the scores are distributed evenly.
Okay.
But the problem now with skewness is that most of the scores are above the mean. Like, excuse me, now we cannot go and report to say people are happy to end the lockdown or people are excited about load shedding because they connect with their families now. We don't know because we don't trust our mean because of the standard deviation that is wider and big. But I would come back to that as we move forward, but it's a good question. That is what helps researchers understand and make meaning of the distribution. So there's no kind of exact value, but it depends on the mean that we have. Some mean scores are 48, depending, like let's say marks for this class, the grade. Like last semester, the mean was 60.1. But now it was because some of the students did not submit, they got zeros. You know what I'm talking about? So if I put it on a distribution, so the skewness of the distribution is caused by some of the scores that are less. So that's where it goes to, if you want to say like that. But there's no actual value to say the standard deviation should be 5, should be 4, should be 3, should be, but it's just, it should be close to the mean as far as possible.
Okay. Thank you, Jabulani. So basically what you're saying is in research, we're always looking to get to that normal distribution because that proves our statistics to be valid, really.
Yes, that is why you see big studies, they want to have a bigger samples. Now that politics of research, the bigger the sample, the higher the possibility of the distribution being normal.
Okay.
So if you collect data from 1 million people, mostly the distribution is going to be normal. That is why we calculate the effect size. We'll get there in week number 9. So we can say there's a significant whatever, but excuse me, hold on. We can calculate the effect size. So the effect size removes the size of the sample. It just look at the variability in the differences, whatever. But we'll do that in week number 9. Don't worry about that. So statistics and research is kind of, there's a lot of politics around it, but now we know the politics of it and we don't cook any data. We just collect data. If we have problems, we go back to the drawing board and do it again so that we help the world. That is why I'm teaching you all this. Okay. Someone to end the meeting kind of positive. Anyone? Caroline, how are you?
Fine, thank you, Jabulani.
Are you following? Are we helping you even?
Sorry?
Are we helping?
Yes, this is very helpful. Otherwise, I think with something to do with numbers, just reading through the textbook is not really going to help. And especially if you're doing it by yourself. So thank you very much.
It's tiring. It's not compulsory on my side. I can do away, not doing. We can skip all the meetings if I want to, but I've taken it upon myself to serve. Not for evaluation. I don't do that. I told you. I'm doing it for you, not for each and every one of you. And we are doing it as a family. We are doing it together like this. I think at the end of, you see how it was useful. So thank you if it is helping. Anyone wants to say something positive, and then we call it an evening. Anyone didn't say anything, please. I can't pronounce this name.
Hi, sir.
So we're speaking? Yes, Ashley, yes, thank you for saying something, yes.
So I'm just using my mother's computer. It's Lara Valenti actually on the call. But I just wanted to double check with you. We've only had one quiz so far and then a quiz for this week, so which is the second quiz. Is that correct?
Yes, it's due on the 26th. And if you check my announcement, the third one is in the other, so we skip a week.
Okay, just wanted to make sure.
I make sure I send a message to everyone on Sunday or Monday. And in my announcement, I say that, I make sure that I explain. So we skip a week. And even in WhatsApp, in the WhatsApp also, I try to explain, because I know life is happening, people can forget. And I don't want anyone to lose those marks. The quiz is their assessments, but the Padlet and exercise like this, we don't grade that. We are just preparing ourselves towards understanding.
Okay, thank you, sir. These meetings are very helpful.
Okay, thank you. I was looking for something positive and then it closed. Bushle, you are not talking to us today. Is it fine? Are you okay?
Hi, sir. Okay.
Every day, every week, you must speak. You know that you must speak every week. So for you to be safe, rather speak at the beginning.
Yeah, I see that now.
I'm watching you, yes. Can you say something to us and then we leave?
I'm interested in the response that Yandi and I have been talking about in the comments, but I guess we'll see when you post it on the Padlet. The one that you said is not usually asked, but you went through it with us today.
Yes, I want to see that one. Yes. Or 3.5, added a third 1.5. No, it's not. 3.5 is in that line. It's not 3.5.
Okay. Oh, okay.
Yes.
Well, but I guess we'll see when we.
But the 3.83 can be correct.
Oh, okay.
But I'm not sure. I'll check. Let's post there and we'll see what happens. But don't spend more time on that. It's not going to come in the assessment. It's just for you to show flex your muscles. But anyway. But your answer is like.
Thank you for the Zoom calls.
Okay.
Very, very helpful. Thank you.
Okay, thanks so much. Have a wonderful. I don't know what we're eating tonight. I told you last week, we just, okay, food is ready. And you see what you don't like. But anyway, sometimes you like it. What can we do? Thanks so much. I appreciate.
Sorry, Jabulani, before we leave, I have a question. Sorry.
Okay.
When does the quiz actually open?
I open it at the beginning of the week.
Because I don't see it on my side.
Is it? Okay.
At the beginning of the week.
Okay, maybe there's an error. Can you check again?
Okay, I will do, and I'll message Edmund. I'll email Edmund as well.
Let me know. I'm the one who opened it, not the admin. You must email me. You must send a message to me.
Okay, I will do.
Is Welisa here? Jabulani is not there. I also checked.
Okay, let me open it now. Let me see.
Okay, and I have another question.
Yes.
It's not on the topic. I just would like to know, how does this assessment work?
Which assessment?
Because like our 2 assessments that we have, because it says that we have 3 days, and in those 3 days we get to pick 1 whole day to do the assessment. Is that
So-
correct?
Yes, so you are given 24 hours to complete the assessment, covering
Okay.
work from week number 1 until week number 5.
And then the last one said it's due in session 11.
Yes. So when you are
That-
done, week number 10, we are done learning, and then you have a week maybe to prepare, and then during that week, that is when it is released to
Oh,
you.
okay.
Yes, yes.
So in those weeks they'll release it on the
Yes.
last 3 days.
Not last, they will send an announcement, I think on a Tuesday or something. I'm like what happened, but last term we had a lot of technical difficulties, but I'm not sure. They are managed by our administrator, but they will send a message to you like a week before on what you should expect and do.
Okay, thank you so much.
Okay. Let's say the 3 days let's say you are free on a Tuesday, you start it like 8 o'clock, but you should submit 8 a.m. the next day. If you are free on a Wednesday, you start like you have 24 hours to complete the assessment. So that is what they mean by that.
Oh, okay. Thank you.
Let me see, maybe there's a technical error. I'm going to open the quiz. Confirm on WhatsApp when we have access to it.
Okay, well, good. Thank you so much.
Okay, thank you. Bye, everyone.
Bye.
Okay, bye.